I need to prove a particular function in general form. We are not given any such function that f is x square or f is x cube or whatever, because these are easy
Hmm.
to find using second order derivative, or there are multiple ways. But here, questions are such a manner that you will only be given that prove a particular general function, a convex
Huh.
or concave function. So you need to write, I mean, you need to prove it using the definition and theorem parts. Okay.
Okay.
So what you will consider, you will define that function that from, just define the span, the domain and range thing, that this function, the value has been taken from these two things. It is moving from maybe natural number to natural number, real numbers to real numbers, whatever it is. If the
Okay.
question is giving you the span, write it. And then
Okay.
you say that it is convex if the condition follows. Now, what will be the condition? Before that, you define your parameters or variables. You are defining what? You are defining x, y, and t. So we have considered three things: x, y, and t. Okay.
Yes.
So we want to show it convex. So for that, either you can have this tangent, one point x and y, and the span for which it is extended to. So what we are doing,
One second, ma'am. T is the tangent here.
P is the point.
T is the
So
point.
let's say if I have this line, so we define it and then we want to find out the slope just
Yeah.
to see the change. So that is that
Yes.
value.
T is the
So
slope.
T is the span for which, the interval for which it is making, we want to calculate that, you know, how
Okay, okay.
how much slant it is having, the steepness.
So
Yeah,
T
the
is
interval.
the interval
Yes,
or let's just say the distance between A or B for
yes,
which we want to find the slope.
yes. Is it fine? Now, if I'm considering that this is t lying from 0 to 1, if this is my interval, so what will be my total weighted, average of two functions? That will be, um, let me rewrite. That will be what? Because t is lying from 0 to 1, closed interval. So I can split it into two intervals. One is t minus 0 and one is 1 minus t, right?
Right.
Now, if I want to calculate the average, like weighted average, then it will be multiplication of x. I mean, it will be x times. So this is for one point, but that line will be made up of several points. So for each x, we are multiplying to have this average, x t minus 0.
Ma'am, I have a doubt here. So
Yeah.
initially we mentioned that T is an interval or the distance between 2 points on a graph.
Yes.
And when we are mentioning T is a uh, oh, okay, okay. Over here we are mentioning that T lies T ka value is lies between 0 to 1.
Correct. That means there are many values for x and y between that interval, right?
Many values of X and Y between that interval. Yes, which means got it.
So
Which
that
means
means if for, huh?
there are, well, let's just say in the line that you have drawn where T lies between 0 to 1, we are
Hmm,
indirectly saying that the distance between 2 points on a graph lies between 0 to 1.
correct. So that means if I'm considering any interval, like any value of x and y, what I'm supposed to do, there will be those many intervals for x and the value for y will be multiplied by 1 minus t. This is the linear combination. You can say linear combination for various values of x and y under the span t. That is from 0 to 1. Is it fine?
Yeah, it's difficult for me to visualize, ma'am. I think if I solve a sum.
That is fine. But you remember the general, what is it called? If I have to write a is equals to bx plus c, y is
Yeah,
equals to mx plus c.
mx
This,
plus c.
this is the linear combination wherein this part shows x value and this is the y-intercept, right?
Yes.
So similarly, if you do the same analogy here, apply that. So this is the span. Whatever is the interval, I have taken one value. Any span it can be, which is lying from 0 to 1. So I have considered
Okay.
for x and for y. So the combination will be x t minus 0 plus 1 minus t into y, okay?
Got it. Ma'am, one doubt here. Why do we
Yes.
assume that from the point T,
Hmm.
when we
Hmm.
move right towards 1, when the interval or distance moves 1, why do we
Hmm.
have to multiply it with y? And when it moves to 0, why do you have to multiply it with x?
So because you are seeing it as a horizontal line, but we can have this way also, wherein I'll be having both of the values. So in that case, you know that the combination in the coordinate is x comma y. So we
Yes.
are considering, if question has given you detailed elaboration, that consider y from this span only and consider x from that span only, then you multiply it with those values. But at the moment, what we are doing, we are considering that my x and y are from this distance. Like I'm considering that my x belongs to 0 to t and my y belongs to t to 1. Is it fine?
Oh, okay. Got it.
Okay, so if I have to define my convex function, convexivity, using the value generalization, the linear combination, the weighted average, then what I'll do, I'll say that, let's say my function is moving from S to R, and I'll consider it as a convex function if whichever value for all, this is the sign of for all
Hmm.
values of x and y which belong to the domain, and there is an interval t, which is the closed interval lying from 0 to 1. So for convex, we have what? Minima, maxima.
Convex is minimum.
So I'll do, this is my minimum for, if you substitute the value of linear combination function, then it will always be lesser than your scalar distribution. So it is as same as that when you were saying that if it is convex and my tangent is here down, so that will give me the minima point. So if I'm considering any of such values, which is the linear combination, it will give me always a lesser value than the separated x and y, which will be above or on the, equal is for on the graph and greater is above the graph. So we are saying that function is convex if you are having at that point. You can consider any point. And let's say this is my f tx plus 1 minus ty.
Okay.
Then that value will always be a minima for all those values which are above it. So how can I say that these are above? Because I
Ma'am,
have
I'm
distinct.
sorry. Could you there's some problem with audio.
Am I? What you? I did not get it.
It is it is very faint. It is cracking.
You mean there is background noise?
No, no. Now it's better. There was distortion.
Oh, let me come up again.
No, no, now it's
Hold
fine,
on.
ma'am.
Okay. I want to say that if it is convex, it will be having minima. So let me show you. Is my screen visible? Like if I'm
Yes, yes.
switching from one tab to another.
Oh no, no. It's just that yeah, we still are on the same screen. Yeah,
Desmo is
now
visible.
Desmos. Yes,
Okay. So let's say if you have considered any convex function, let's say x squared, it's convex, you know, right?
yeah,
So if you consider any of the scalar multiplication, let's say it is 2x squared, then also it is convex.
yes,
You can change
yes,
it
convex.
anyhow, right? And then if you want to have one affine function, like if you add any scalar to it,
It moves up.
yeah, it moves up, but it is still convex.
Convex. Hmm.
What I'm trying to say, this is visible, my note.
Yes.
Okay. So what I'm trying to see here, if you have any such values, like if you want to find out that what is your F2, what is your, if this function is convex at F5, okay. So you have your function, for example, 3x square or something. If t is lying from 0 to 1, let's say 1x square or 2x square. You can have here also any such value, 1 minus t. Uh, if you are substituting t as 1, so this will give you 0. So only 3x square will be left.
Yeah.
And if you are substituting t as, let's say, zero point 0.5, so zero point 0.5 f by. F by is
Ma'am,
actually,
you're still on Desmos only, right?
no. Okay, let me switch. I'm sharing my whole screen now. So
Yeah.
let's say
No.
you have to
Hmm.
find out that whether this x square is convex at F2, okay,
Okay.
or F. So this is your combined value as 2
Got
and
it.
5. That will always be less than the limit of this. How? Let's say your t is from 0 to 1. So if you take t as 1, let's say, so this will be
Hmm.
fx plus 1 minus 1 is 0. So this is 0. Is less than fx, less than or equal to fx. What is fx? I have considered it as x square, right?
Yeah.
So I'm audible, right?
Better now.
Okay. So this is f2. How have I got this fx plus 0? Is it fine for you?
Yes, yes. We have taken the value of t, the scalar value, as 1.
Yeah. So what is happening? You can see that it is equal to x square. Now, if I consider any other value, let's say x is t is 0.5 now. So this has changed into 0.5 fx, which is x square, plus 1 minus 0.5 is,
1 minus 0.5 y.
and what is my fy?
My f,
So if function is x square, this is fx. If it is fy, then it is y square.
yeah.
But actually, my y is x square only.
Uh,
What is fx? Value of function at x. So that will
at
be x square. What
x
is
square.
fy?
Yeah.
At y.
Y square.
So what do you think? This value is always lesser than these values?
Yes, obviously, yes. Oh,
Yes. This is what they are
once.
saying in difficult form, that for being a convex function, in order to being a convex function, the value of,
Ma'am, is it less than that? 1 second.
so now I'm not considering x as 2. If I have to find out the value of what? If you are substituting x as 2, put it here.
Yeah, so again into 0.5 would be 2 plus 2, 4.
Yeah. So if you substitute here, this will be 4. And you have y square as well.
Yeah,
Right?
but then y square, yeah, what if, ma'am, again over here, we are assuming that we'll have the value of y square which is more than 2
Yeah. So what will
for
happen?
it to be. Yeah, but then why are we assuming that the value of y is more than 2?
So if you have, you can see that here, this is my graph. If this is my graph, this is lying in what? First or second quadrant.
Yeah,
It will give me more value than that value where in which is the lowest minima for me. 2 is the minima where tangent is touching that point. So all those values which are there, even if I want to put the minimum value, that will be 2. All those values which are there will be above then, because even if you take negative value, that will give you positive, right?
ma'am, I did not understand this point. I did not understand why we assume, why we have to give y the minimum value of y as 2.
This thing, if I have considered this as y equals 5, okay,
Okay.
what do you think for this graph y is going to be? Only positive,
For,
only up.
yeah, yeah,
So the minimum value will be y equals 5. Rest all other values will be positive. And
yeah.
above that, like greater than those values. Is it fine?
Yes, yes.
So this is how we are taking and saying that this will give me,
Ma'am, but in this case, we're assuming the value of x to be 2, right?
yeah,
At minima. Then how
huh.
can we assume that the point of y, value of y is going to be greater than 2?
Okay, so for that we need to see, if I take the example of this one, my vertex is 0 comma 5. So I'll
Hmm.
substitute my x as 0 and y as 5. Now tell me.
Okay. Now I'll solve. Now I'll solve both, right? Linear form as well as the
Yes.
yeah, scalar distribution. Uh,
And hold on. My function
What
for
about
this is
the
what? This function is 5x square plus 5. So function's value is 5x square plus 5. My vertex is 0, comma 5. And let's say t is, so for value of t, it should be,
ma'am, could I solve it with x square पहले?
अच्छा ठीक है. तो एक मिनट मैं वर्टेक्स बता देती हूँ x स्क्वायर का. x स्क्वायर का वर्टेक्स 0 0 आ रहा है. Find this out.
Over here, we are assuming that x equals 0 and y equals 0.
Yes.
And what is the scalar value, ma'am?
So that should be lying from 0 to 1. So you consider,
Okay.
if you consider 0, or even if 1, that will give you f0
Okay.
is less than or equal to 1, 0, right?
Yeah.
It is satisfying, right?
Yes. So it's going to be f1 in this case. So x plus fx हो जाएगा इसमें. Zero. Fx is 0. Uh,
Fy is also 0.
hmm. Fy is also 0. And your scalar distribution would be this. Ma'am, it's 0. Scalar distribution is also 0 in this case.
You can say that, which is appropriate condition, right?
Yeah.
Because equal sign holds here. So what I'm trying to say, it is just a complex way of writing it, okay? And why we are using it? Because in I have seen your question papers, they are using this form only, where they are using this scalar and linear combination instead of saying that it is increasing or I mean, there are several questions. One is using second order
Okay.
derivative, one is using only statement based and its significance. So we should know. So for convex, the condition is the linear combination has to be smaller because it is minima. Uh, Smaller than what? The distribution of scalar
Scalar distribution of.
multiplication. Yeah. And then
Ma'am,
if
so, oh, this makes sense. So, you're technically the value of a function
hmm,
given any point x or y,
yeah.
when it is in the form of a linear combination,
Hmm,
and if that linear combination is a minima,
hmm,
any point above that when is going to be a point where you have a scalar distributed form of the same function,
yeah.
or it's going to be equal to that point. Or now I understood.
Which is convex. So this is the same thing. We are just
Convex.
elaborating. Yeah. Now what
Okay.
if you have to convert it into concave thing? So what you will write the same thing, a function Only difference is
In this
what?
case, everything has to be less than the your linear combination must be less than the scalar, less than or equal to the scalar distribution, where your linear combination is the relative maxima.
Yes. So this is, have you jotted this down?
Yes, ma'am, I've written this. Ma'am, have you unmuted yourself?
Am I audible? जवाब
Yeah.
आज
Yes,
भी
yes.
परेशानी हो रही है, आवाज ऐसी कर रहा है. हाँ. So this Wi-Fi person is here and he's
Okay,
saying
okay.
that he'll fix it, but yeah. Anyway, so concave is the maxima. Is it fine?
Yes, ma'am.
So we have so far learned about one thing, that tangent and chord position, in order to tell that this is particularly convex or concave. Secondly, the second order derivative test. And thirdly, when we have this general definition in the form of linear combination. Is it fine?
Yes, ma'am, fine.
What is an affine function? So I told you about constant function. I have 3a log y plus 1 plus x. Tell me, this function is concave or convex?
Y plus 1.
I mean, whether, firstly tell me whether it is concave, convex. Tell me whether it is semi-definite, positive, definite, negative, definite, or indefinite using Hessian metrics. Yeah. If you want, I can
Okay.
give you the constraint.
Ma'am, x is greater than or equal to?
A. Basically, A has linear combination. These three are constraints. This is from your question paper.
Ma'am, so using Hessian.
Yeah.
So y dash would be. Ma'am, but over here, x value of x and y, you have given equal. Y dash equals 3a.
But y dash, which y dash? Is it partial differentiation with respect to x or y? You need to find out all those four elements, right?
Yeah, the partial differentiation in terms of, oh, yeah, y dash x in terms of x would be a log. Ma'am, so here in terms of x would be 3a. No,
What is this?
ma'am, is y dash x 1?
So partial differentiation of f like y with respect to x is what?
Yeah, I'm not able to differentiate the first part of the equation.
Okay, so basically it is what?
No.
If you are doing it with respect to x, x is what? I mean, y will be
X
considered
is
as constant.
constant. So y equals everything with y is 0 then.
And if it is y, so you are not able to do this one, right?
Yeah,
So for x is 0, for this one, you can assume it as log y something. So log y is what? 1 by y,
1 by y.
and then the derivative of y is 1. So it is what? 3a over y plus 1, right?
Yes. Y plus 1. Got it now.
Now find out this one and this one.
So now double derivative would be the quotient rule.
Yeah.
Yx double dash is equal to 0. Y double dash with their double derivative would be uh, plus 1. 6a divided by y plus 1 the whole square.
6a.
Yeah, ma'am.
So you need
You
to
can
write
say.
it this way. 3a y plus 1 raised to power minus 1. And you want to derivate this, right?
Oh, yes, yes, ma'am. 1 second, 1 second. Sorry.
Huh.
Equals 3a y plus 1. Ma'am, I kept y plus 1 in the denominators itself.
So that is
So,
also fine if you want to keep it this way, that quotient rule. So denominator square, denominator as it is, numerator's derivative
so that would be 0 minus
minus.
3a derivative. So that is 3 minus 3a into 1 plus 1, 2.
Yeah. Or else you could have done this way. Y plus 1, you consider it y. So
Ma'am,
differentiation
ma'am,
of
over
y.
here,
हाँ,
ma'am, ये है ना by 3 minus 3a into 2 होगा ना?
to y to
मैम
uh,
y plus 1 का डेरिवेटिव.
हाँ. So it is not integration that we have to add. What happens?
Oh,
When,
no, 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 sorry, sorry, yes.
yeah,
No, it's so silly.
it's fine. So this is how we do. So if you want to do it
Yeah.
using caption rule, that's fine. If you want to do it this way, that 3a is constant. This is, let's say, x. So what happens? Minus 1 you bring into the coefficient thing and you subtract. So this is minus 3 y plus 1 whole square, right?
Yeah, yeah. Yes, ma'am, I did, I got it.
So tell me whether it is semi-definite or definite or what.
Ma'am, so
So what do you write? How do we calculate? Do you remember? Can you recall?
yeah, so we see we find the determinant. We make a matrix first. Then now we calculate the cross differentiation also. So that is one second. Yeah, cross partial differentiation is zero.
It's okay, fair enough. So what do I write here? Firstly, first
One
element will
second.
be
X1 equals zero. So the first element would be one.
y.
No, no, no. First is zero.
Hmm.
Zero, zero minus 3a divided by y plus 1 the whole square. And yeah,
Okay.
0 minus 3a divided by y plus 1 the whole square.
So what's the determinant?
Determinant of the square matrix is nothing but the product of its principal diagonal.
So we do this cross. First we multiply
Yeah,
this
yeah,
and
so it's
minus that.
zero.
Yeah. So zero means what condition?
Ma'am, so if it's zero, zero is semi-definite.
Perfect.
When we
So it's
include
semi-definite.
semi-definite.
Now need to find out whether it is positive semi-definite or negative semi-definite. For that, I need to check it with the constraint. So y
Yeah.
is greater than 0 and x is greater than or equal to a. So if you consider anything and putting here, it is always less than 1. This is also the constraint. So if you substitute any bigger value, 0, 1, 2, 3, 4 of y, and then you consider any value, we don't know though what is a. So if you substitute any value, it is giving you, this linear combination is giving you the value lesser than 1, right? Yes, Purujit? Hello? Am I audible? Hello? Hello, Purujit, am I audible? Hello? हम कर देता है इंटरनेट. Hello, Purujit, am I audible? Purujit?
Am I audible, ma'am?
Yeah, you are now.
Okay. Yes, yes.
So I'm saying now I need to find out whether it is positive or negative semi-definite. So you can see, if even if I'm substituting any of such values greater than y, I mean greater than 0, whatever it is, and whatever the value of x is, it is giving me lesser than 1, right?
One second, ma'am. Could you come again?
So these are the constraints to
Constraints.
I need to find out. These are the restrictions I need to put the values of x, y, and a within these limits. So if I substitute, let's say y 100 or 1000 or 5000, whatever, and I consider a anything, but a I don't know, it is arbitrary constant. But whatever I put here, the condition for linear combination is that it will always be lesser than or equal to 1, right?
How could that be possible, ma'am? Because over here,
This
um,
constraint given in the question itself.
okay.
Question has asked me to find out whether this function is semi-definite or concave convex. I mean, and concave or convex. Find this out. If the possibility for y, x, and everything is this. Okay?
Got it. So that's a constraint that has already been given to us. So irrespective of the value that we put for y
Huh.
and x,
Yes.
where a is an arbitrary constant.
Yeah. So now tell me, it will give you less than one value, less than or equal to. So what do you think? Is it positive semi-definite?
Ma- Ma'am, it could be anything. It could be positive. Since it's less than one, it could also go negative.
So if I consider this y plus ax is less than or equal to 1 here, right? So this value, anyways, I'm getting it negative, right?
Yeah.
So that means what it will be. I mean, the possibility of having any such thing, because my derivative, second order derivative of one of them is negative. So it is going to give me negative semi-definite, right? Because if it is 0, so that we know that it is inclusive and
It is
semi-definite condition.
semi-definite. Yeah.
But for negative or positive, I need to check whether the value of A is negative or positive, right?
Okay, ma'am, I'm writing that down. One second.
Huh.
Need to find since minus 3a is negative. The function is negative. Ma'am, so I get the method. I get why we are saying it, but then I'm not able to understand
See,
if
this
one of
is
my derivatives, second
hmm,
order derivatives is negative,
hmm.
how would I know that the value of the function is a positive, is a negative semi-definite?
Okay, let's go through the constraints again. Y is greater than or equal to 0 and x is greater than or equal to a. So this is the thing. Tell me what is a here.
A
This
here
is
is Yeah, 1 minus y divided by x.
I'm considering y as greater than or equal to 0.
0. Okay.
So the least value, the maximum value which we'll get is what for a k?
Is when y is equal to 0.
So that is what? 1 by x.
1 by x, yeah.
Yeah. And then rest all values will be what? Negative.
It's going to be 0 or negative.
0 and negative. So can we say now that it is negative semi-definite? It is not only dependent on, don't think it this way that, okay, rest all values are 0. The only determining factor which we are having here is this one value, okay, through which we find out whether it is convex, concave,
Hmm.
and here also y is very much clear. It is greater than or equal to 0. Equal to 0 we can take because it is not making denominator not defined. Rest everything is dependent on the constant a, right? So you find out the value of a, based on that only we can justify whether it is the condition of negative semi-definite or what.
Ma'am, I did not. Ma'am, could you please repeat the last sentence? I did not catch that.
Okay, so if you are not getting it in this way, you can
Okay.
also do it using the eigenvalues form. Then you will find out a minus lambda I, right? What
Yes.
will be the determining factor here? Again, only the fourth element is
Uh,
something which is making it negative or positive, right?
yeah.
So what is fourth element having? A and Y. It is negative. Rest of that, A and Y will determine. Rest, if we talk about those values which will define that whether it is negative or positive. A and Y, right? Why
One
we know
second, ma'am. The fourth element of a matrix. Thus, here it is A and Y. Yes, ma'am.
only A and Y are the determining factors. Now, Y is absolutely given, only the which is greater than or equal to 0, but it is in denominator, which will making it small.
Y
The
is in
bigger
numerator, no? No.
Y is in denominator.
Oh, acha, okay, right, right. Over there, yes.
The bigger the denominator, the lesser the fraction is, right?
Yes, yes.
So this is one factor. And then about A is what? From here, if you substitute y 0, A is your 1 by x.
Yeah.
So again, if you putting all those values of x which are greater than or equal to A,
Hmm.
it is making it lesser because denominator is again increasing,
Yes,
right?
denominator is increasing. Yes.
So it is making it in all possible manner negative. Negative
Hmm.
semi-definite because it is leading to less than or equal to 0 condition.
समझ गया. Got
If my
it.
determinant is less than or equal to 0, then only I can say that it is negative semi-definite condition. It is in at all, it is not, I can't make it greater than or equal to 0. You can try substituting different values of A and Y,
Hmm.
and then you will see.
The more sums I'll solve, I think the better it'll get.
Okay. And if you have any doubt, you can ask. Convex and convexivity and concavity. What do you have to say about it here?
Ma'am, so negative, sorry, negative semi-definite है. Ma'am, for convexity and concavity, do we? हाँ, we have to find अभी.
Can you say
For
anything
convexity and
from second
concavity.
derivative?
हाँ, yeah, second derivative, obviously, we can say. So the second derivative over here, oh no, मगर it's partial.
That's fine
Uh,
because others are zero. So only this is the determining
yeah,
factor.
zero and negative. So, ma'am, it is concave.
It is double derivative. Is it having minima or maxima?
Ma'am, so but here it is negative, right?
Correct. Double derivative is negative. Double derivative, not first order.
Oh,
If second order derivative is negative, that is the condition for minima or maxima.
oh, second order derivative is negative. That is a condition for maximum, ma'am. No, no, no. That is a condition for minima.
Minima, that is
Yes, that is convex.
convex. Good. Let's come let's come back to a fine thing. I have told you about constant and identity function. Can you tell me what is identity function?
Ma'am, identity matrix
You know,
function is
identity means whatever value
to.
you put for y, that is the same value for x.
Oh, that's the same value for x. Yes, yes, yes. You have told, ma'am.
Yeah.
So
And
it's
what
your
is
fx
constant?
equals x in this case.
Correct. What is constant
You have
function?
written. Ma'am, is constant function uh is equal. Ma'am, does constant function give us the same range for every domain?
Right. For example, y3. So that is this constant. Okay. The affine function is also similar. What we do, we have a linear function and we add some constant term to it. That becomes affine. For example, just like I told you, ax plus b, 2x plus 3. So a scalar matrix. Here you have A as matrix, any scalar matrix. X
Hmm.
is your vector, input vector, and B is constant. Yeah, do you remember
Yes.
matrix method? And we
Yes.
use it for that. So this is a fine function. Why I'm telling you this? Okay, tell me if you have x square, any value here, x1, x2, x3, this can range from 1 to m, and you have x raised to power 1 by 2. Which is convex, which is concave?
Ma'am, the left one is convex and the right one is concave.
Reasoning.
Ma'am, because yeah, the so the any value of x, the value of x, the value of the function keeps reducing in the second one, and the value of the function keeps increasing
Nice.
from a point of vertex in the left one.
If any function, that's correct. If any function, in any function you find flat spots. So these are when there is no change in y for change in x, that is the slope is constant. What do you think this function is convex, concave, or what?
Oh, I, it looks like a convex function,
Okay, tell
but
me, let's say this is minus 3, this is 3. And this is 4 or 3, let's say anything. Now tell me, where is it decreasing?
-3.
At
No,
-3.
it's not.
This is the interval
Yeah, it's
decrease.
-3. It is decreasing.
This is the increasing.
Yes.
So here it is concave, here it is convex. Here you will say that it is neither concave nor convex. Okay?
Yeah.
So when I have to say a function is strictly concave or strictly convex, for that I need strict inequalities. Do you know what are strict inequalities? When
Yeah, it's
you don't have equal sign, inclusive.
equal signs. Yeah,
So that is
got it.
important for any linear function. If you have any linear function, because you see the line, this is what I made earlier. Y equals x, I cannot say it has negative values also, it has positive values also. So it is also both convex and concave, right?
One second, ma'am. Ma'am, two steps back. Can we move?
Yes, I have
This is
considered.
a little bit of an information overload.
Acha.
One- It's, okay.
So let me tell you
Strictly.
again from this linear function, right?
Huh.
So if
Yeah.
I'm considering any linear function, that is the variable is having power 1, and the maximum is if it is multiplied with a vector or being added to some of the vector, whatever. So at the moment, I'm considering this y is equal to x. That is y1x. Yeah. Tell me
Yeah.
this function, whether it is concave function or convex function.
Ma'am, it's increasing, so it's convex.
But if I go with that concept having negative and positive values, so here y,
No. Yeah, it can. It's increasing or decreasing.
so whenever it is linear
1.0.
function or affine function, for example, if some constant is added, then we can consider it both concave and convex. Now, in order to find out the strict values, we have to
Huh.
divide it into intervals,
Yes,
right?
ma'am. Got it.
So by intervals, we can say whether it is convex or concave. So here are some properties which I have told you so far. So far, firstly, tell me if f is strictly convex, what will be minus of f?
If it's strictly convex, minus of x will be strictly concave
Right.
because if it's greater than 0, then it's less than 0. No, greater than, yeah, so it's strictly
If
the inequality inverses.
correct. If you have a scalar multiple and that function with which it is multiplied, that is a concave function. So what do you think the product is?
A scalar multiple of a concave is a concave only, ma'am.
Correct. And if it is convex, so it is likewise, okay?
It will be a convex.
Tell me if you have infimum of or supremum of a function. Infimum is for what?
Ma'am, it is the Is it an addition? Is this infinite value of the minimum?
Correct. So what we are having, if it is the conclusion of this statement only, if you are finding out infimum of a concave, that will be concave only. If you are finding out
Could you explain what is an infimum case?
infimum is the least value, supremum is the maxima, infimum is minima.
Okay. Oh, okay. That's a different word for maximum and minima.
Yeah.
Got it.
So it is as same as the B pointer, wherein if you are having concave function, okay, and you want to find out the minimum value or maximum value of it, be it infinity, doesn't matter, like interval can be 0 to infinity, anything. But for concave function, that value, let's say, where I'm writing, if this is your concave function, let me draw it there. This is your convex function. And what is the minima here? Infimum point?
0, 0.
0, comma 0 is the vertex. Like the function will be having minima at this point, right?
Yeah,
But what will be the
at that
infimum
vertex.
value or minimum value? That I need to put the value of x and y into the function back, right? That is again 0 for this function.
Yeah, both x and y will be 0.
So did you get the pointer infimum and minima? Minima is the point where we find the minimum value, and infimum is the minimum value of that function. Is this fine?
Yes.
So the
Little
minimum
little
value.
confusing. Honestly, I
अच्छा
look at the recording, ma. It was थोड़ा ज़्यादा information.
अच्छा देखो मैं दोबारा बोलती हूँ. Let's say if I have fx is equal to x square, I have found this out that this is my minima.
ठीक है.
So I'll put the value of x and y here. The value of function at the minimum point gives me, this is the minima, this is giving
Yeah,
me infimum. Is it fine?
ठीक है. Yes, got it. The value of the function at the minimum is give me infimum. समझ गया.
Correct. Now, what I was trying to say with that point, that infimum or supremum of any sequence, if the sequence is concave, the infimum or supremum will be concave. If the sequence is convex, the infimum or supremum will be convex. What I'm
And
trying to
what is
say,
the sequence here?
sequence can be, let's say if the values are given, this is the x square, and then if you have this sigma, this is x square. But if you make it sigma x square for any such value, which is x1 square, x2 square, are you getting my point? This has become the sequence now.
Yeah.
So for that, if you will, because this is the convex sequence, so the value, the function's value which you will get at a particular point, that will also be convex.
Right.
And if it is a concave series, that will give you the convex values. That is because you can write x as 2. So this is also a function. Though it is giving me a point, But this is also increasing function, right? So it is constant. So it is
Yeah.
a convex, right?
Oh, it is. I'm able to understand, but थोड़ा सा it is.
I'll give you a hint when the question comes. You just hear me
हाँ,
out. What I'm trying to say, these are the properties which we are going to use. Very, very
ठीक है,
important
ठीक है.
thing here. And that is contour set. By now, we have talked about a single point. What about if we are having the limit, the whole boundary, the shaded region of inequality? Let's say this is the
Hmm.
curve. So this is my upper contour set. All set of all those values. Upper contour set.
Got it, ma'am.
And then if I have to find out the lower one, let's say this is my point.
Yes, ma'am.
Let's say this is my x naught. This is one function. Which sort of function is it? Convex or concave?
This is convex.
So I'm
Oh,
having
yeah.
my tangent at x naught.
Hmm.
So this x naught is having a vector. Vector means it is going in this direction, xy plane. So ij vector, the direction which it is having, this pointer x naught, is let's say p in this way. Do you get this p?
Okay. Yes.
Now, this is a scalar multiplication which I can have px naught. If I have to create, I mean, upper contour set, it will be above tangent, above the graph, this one. All those values which are greater than x naught, right?
Yeah.
And for lower contour set, of course, I
Right.
cannot have those values which are below the tangent because that is not my, this is not lower. Why? Because this is not even my graph and the expanded version of graph, the curve. The lower contour set will be those values for which the graph, which are the values which are bounded by the curve and the tangent, because it is a convex. So I'll be having minima.
Right.
So what will happen if I have to define a function S to R where the domain is the subset of R, everything, then the upper contour set will be defined by, let's say, upper for Y, where X belongs to the domain, such that the value for fx, all you need to make a set of all those x for which if you put them in the function, that will be a minima. Sorry,
Right.
hold on. Because it is upper contour,
Thus minima.
if it is lower contour,
Is f of x less than or equal to f of y.
Okay. Now I'll
Hmm.
explain you using the graph as well. So these are two conditions for lower and upper. There is one supporting hyperplane also. These are the terminologies which we are going to use.
Okay.
Supporting hyperplane. What do we mean by that? So this vector which I told you, which is giving it a direction for x naught. So this is supporting hyperplane is a vector. Am I audible?
Yeah, yeah.
I can't write. Okay, it's working now. A vector P, it is small p, which supports the set for which there is x naught. This P is defining x and dividing it into lower and upper halves. How? It can be px or it can be px naught. Different values. When you multiply this vector with x, you can get greater or lesser value than your general points,
Noted,
right?
ma'am.
So these are two conditions. So your supporting hyperplane is helping us to divide this graph into two forms, two half spaces. One is H positive and one is H negative.
H negative.
So if it is positive, then you have all the values of x such that px is greater than px naught. And if it is negative, then you have all those values which are for which px is lesser than or equal to px naught. Is this fine?
Accept. Got it, ma'am.
You can have anything. I mean, x for x naught, it is vector. That's why you will be having both. If it is 2D plane, you will be having both values. For example, 1, 1, right?
Graphically एक बार can you show this?
Definitely, I'll come to that. You tell me if it is 6x, which is a constant function. Not constant. It is a linear function.
Hmm.
Tell me whether it is concave and convex.
Ma'am, so this is linear function. This is convex, ma'am.
This is convex because it is giving me what? Positive value. What about 3x cubed?
Yeah. Uh, cubic function. Ma'am, this I'm not sure.
You can see that this is the limit.
Ma'am, it is not neither.
I mean, if you want to span it, if you want the full, if you want to define it for full function range, then you will say that it is neither concave nor
Positive
convex,
or
or the
concave or negative, concave
over
or
the
convex.
yes, over the entire domain. But if you want to
Huh.
divide it into the intervals, then you will see, because it is 3x cube, so double derivative will be what?
Double derivative will be yeah, 9x square. That's first order derivative. Double order derivative would be 18x.
Now, if 18x turns out as
Greater
positive
than
and
zero. So
negative,
this
that
is
will give you what? The condition.
so the first interval is convex and the second interval is
Yeah, so
concave.
this is how you have to set up the limit. Now, when I was telling you about x, you were asking me the graphical.
ಮಧ್ಯಾಹ್ನಕ್ಕ ಸಾಯಂಕಾಲಕ್ಕ ಮಾಡ್ಲಿ ಕೆಲಸ ಮಾಡ್ಲಿ ಸುಮ್ಮನಿರು ಸಾಯಂಕಾಲಕ್ಕ ಸಾಯಂಕಾಲಕ್ಕ ಅಂದೆ
Let me pass it through
ಸರಿ 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 ಓಕೆ
0, 1. That is y minus y1. If you have to, I have considered this function. Am I audible to you?
Yeah, ma'am.
So I have considered this function y equals e raised by x. Can you see?
Yes.
It is having its vertex as 0, 1.
Yeah.
Tell me, is it convex or concave? With the concept of chord and tangent?
The concept of a chord and a tangent, it is convex.
Yeah, it is convex. Now, if I consider any particular line, its first point is 0, 1. Can you suggest me the equation of line which can pass through this vertex?
Ma'am, so it could be through that vertex, it could be x square into x square x square plus 1.
X square plus 1. How did you determine it?
Ma'am, so x square, the vertex is 0, 0. So plus 1, it increases by 1. They will pass through that point.
You are saying what? X square?
Plus 1.
This is not line, this is parabola.
Oh, my bad. Yeah, yeah, a line. Ma'am, would x plus 1 pass through that? Yeah.
Okay. So once you get this, I'm trying to explain you the hyperplane. So this is your 0, 1 is your x naught. Okay. Is it fine?
Yeah, ma'am.
So 0, 1 is your x naught. Now you can divide this whole plane into two parts. One, when whatever value you will put for function, which is e raised to pi x, it is going to give you greater value. If you put the values greater than x naught, right?
Yeah.
So one is the function. This is the limit. Whatever value you are putting down, if it is greater than the values for x naught, then it is giving you the upper contour, right?
Yes.
And if it is lower than
Less
that
than
of
x
x
naught.
naught,
It is giving us lower contour above the
low,
tangent.
yes. I'm not considering those values which are below the tangent, because that is not defining my curve.
Yeah.
I need to revolve around the curve and that value which is the x naught. Okay. So what I'm trying to say, I have considered one p value. Let's say, what is this value? Uh, this is minus 20 comma 20, right?
Yeah.
So p I have considered minus 20 comma 20. X naught is what was it? 1 comma 0.
Yes. No, 0, 1.
So these are my values. Once I start putting down the values into the function, it is dividing me, it is giving me two half spaces. For one, if I have px naught and px, okay, the linear combination of these two values. If I have px naught and px, if my px is greater, that is here.
Yeah,
It
that's
is
an
upper
upper
half
contour.
space or upper contour. If
Upper
it is
half space.
lesser,
Yes. So
then
it's a
it is
lower
the
half space defining the curve and lower contour.